Good morning, my YouTube viewers. It's Crystal here. I'm just here this morning because I wanted to give you another code review. This code review is going to be on a Kaggle competition. I would like to say that I worked on the Kaggle competition yesterday, all day yesterday. And basically, when I originally worked on the competition, I worked on it with the Extra Trees Regressor from sklearn, and I got a bronze medal for that. But I've just even stopped posting when I get bronze medals because I've got so many bronze medals. I mean, when I get good enough to where I can get a silver medal, then I might post about silver medals, but I don't want to keep on posting on bronze medals. But I did get a bronze medal for it, but I decided that I wanted to try TensorFlow because TensorFlow is supposedly more popular than sklearn. And in this instance, I got a better score with TensorFlow than I did with Extra Trees, so that's why I'm giving you the code review using TensorFlow instead of Extra Trees. So it's all really interesting. I've also been studying this library called JAX, and JAX is supposed to be overtaking TensorFlow for research purposes at least, and JAX was written on top of NumPy, and it's supposed to be so much better than NumPy, so I've been studying JAX as well. And JAX is a library in Python, so at some point I will start making videos on JAX as well. But for the time being, we're just going to be using TensorFlow. I think a lot of people got upset because they amalgamated Keras into TensorFlow. But that, to me, as far as I'm concerned, that's one of the good things about TensorFlow because it's easy to make a neural network with Keras, whereas TensorFlow, it's more difficult. And JAX is just a completely different ballgame. It's supposed to be a better version of NumPy, so I will be making posts when I learn more about JAX and I learn how to make algorithms with JAX. But going back to the code review for store cells, we're going to predict on sales quantity in our dynamic grid world. And so these grids are 150 by 150 squares, and it's a Kaggle competition. So what I will do is I will leave a link to the Jupyter notebook in the description box down below, so if you want to look at the code, you can. So you can see here that on the TensorFlow, I got a best score of 556.7506, and I thought, okay, well, I'm going to leave it at that because I've got lots of other things to do as well. And so because I've got lots of other things to do, I can't spend all of my time on just one data set trying to win it. I wish I could. I wish I had the time to be able to devote just to one particular data set and work on it until I finish it and win the competition. But I can't do that, not right now anyway. So what we're going to do is we're going to read the problem statement. The problem statement is predict on store cells in a simulated grid world of 150 times 150 squares. And so I wrote this program in Kaggle's Jupyter notebook, and it's stored in my Kaggle account. So after we have written the program or created the program, then what you want to do is you want to import the libraries you're going to use. So the libraries that I've used for this program are NumPy as NP, which creates the numeric arrays, NumPy arrays, and it performs numeric computations. We're going to import pandas as PD, which creates the data frames and series and also performs data processing. We're going to import OS, which goes into the operating system and retrieves the files used in the competition. We're going to import TensorFlow as TF, which creates the neural network. We're going to print out the version of TensorFlow, which is version 12. The reason why you need to print out the version of TensorFlow is because TensorFlow goes through so many changes. And so I don't know what's going to happen with TensorFlow, because I've read on the internet that JAX is going to replace TensorFlow. So they're going to say for research purposes at least. So I don't know if that means that they're not going to put all the great Keras into JAX, if they're going to make us create our neural networks on our own from scratch with JAX. I'm not sure exactly what they mean by that. Then they're going to import matplotlib.pyplot SPLT to visualize the data, and they're going to import Seaborn as SNS to statistically visualize the data. So you can see we're on version 2.12, and TensorFlow goes through a lot of changes. So we'll just have to see what's going to happen with TensorFlow. Then we're going to set the seed. We're going to set the seed in TensorFlow and NumPy. So tf.random.setSeed42 and np.random.seed42. So you set the seed to make sure that the program runs the same every time you run it up. We're going to use OS to retrieve the files from the directory, and the files that we've got are train, test, sample submission, and supplemental cities, and they're all CSV files. So now what we're going to do is we're going to take pandas, and we're going to use pandas to convert those files to data frames. So I called them train, test, submission, and cities. So this is your train file. You can see it's got an ID, city ID, price, store ID, quantity, and add level. You see the test. The test has everything that the train file has except for quantity, because quantity is what you're going to be predicting on. And now we have information about the cities, which is city ID, population, education level, median income. So then we check submission. This is what Kaggle wants to see when we submit our work. Now what we're going to do is we're going to join the train and test data sets. So train df equals pd.merge train cities on city ID. So you can see that this is train df, and that's what we're going to be using. You can check the info. You can see they're all numeric except for the city ID, which is an object. And then test tf equals pd.merge test cities on city ID. So you can see that that's the same format as the train df, except for the fact that it doesn't have quantity, because that's what we're going to be predicting on. We're going to check for null values in the train df set. You see there's quite a few null values in the price, the ad level, and the population, and the median income. So what I did was I dropped all on the train df set. I dropped all of the rows of data that had null values, and so that decreased the size of the train set to 20,621. We check for null values in the test df data frame. You can see that we've got null values in price, ad level, population, and median income. What we're going to do now is we're going to drop the ID, and the reason why we're going to drop the ID is because each row of data is automatically indexed in the data frame. And then we're going to drop the city ID because it has too many unique values. If I had wanted to, I think I originally tried to encode the city ID, but I couldn't encode the city ID because the city ID in TestDF had different values than the city ID in TrainDF. So I decided that the best thing to do would just be to drop the city ID altogether. So now what we're going to do is we're going to impute TestDF's missing values. The thing about the missing values in TestDF is all of the missing values are numeric. But I did some research and I found out that you can fill an NA with pad. And when you fill NA with pad, then what that does is it just fills it with the previous number, because I could have filled NA with the mean or the median or the mode, but that's not going to give you the best answer. And that's what I thought, because there were so many null values. I thought, well, that's not going to be good. So I decided to try out pad. And then so when you have pad, what happens is it imputes the null value with the preceding value. And so I decided I'd give that a try and see what happened. And so we checked our null values again, and we don't have any null values, which is good, which is what we want. So now we're going to analyze the trained DF. We're going to analyze the quantity of trained DF. So you can see there's your quantity right there. And now what I did was I created some box plots. So this is a box plot on the price. And you can see that price range number 5, it has the highest quantity, but price range number 7, it has the lowest quantity. So that means that people want to buy the less expensive plots. And now we do a box plot on the store ID. So you can see what the prices on the store ID are. If you want to, there are 23 values in the store ID, and you can see that number 0 and 1 seem to have the highest quantities. And now we do a box plot on ad level. And so you can see that the higher the ad level, the higher the quantity. We do a box plot on education level. So the highest quantity for the education level seems to be 6. Now what we did was we did a scatter plot. We did a scatter plot on the population. And you can see the higher, most of the bulk is between 0 and 75,000 really, but that just tells you the population and the quantity, and it does show you that you've got a few outliers. And now we're looking at the median income and the quantity. So 1750 to 2000 seems to be where you get the highest quantity. Now what we're going to do is we're going to define our x and y variables. So y is train df.pop quantity, x is train df, x test is test df. Then we're going to normalize the data. We're going to use sklearn's min-max scaler. And so x scaled equals scale.fit transform x, and x test scaled equals scale.transform x test. Now we're going to use sklearn to split the x scaled and the y variables into training and validation sets. So you can see that. And now we're getting into Keras Tensorflow. We import the modules that we need for Keras Tensorflow. We create a model, we call it store cells. And then the first hidden layer is 64. The second 64 neurons. The second hidden layer is 32 neurons, and the output layer is only 1 neuron. And then we're going to compile it with a loss function of mean squared error. The optimizer is RNS-prop, and metrics is going to be MSE. So we print off the summary of the model, so you can see a summary. And now we train the model, set it up for early stopping, and we train it for 200 epochs.